So as we were discussing in the previous episode, we're now going to look in depth at this second law of thermodynamics, that the entropy of the universe is always increasing. So the first question we have to hit once again is, what is entropy? And again, it's the amount of randomness or chaos that exists in a system, in an object, in a reaction, you name it, right? How chaotic, how disorganized is a particular doohickey, right? We'll keep it as broad as possible. And so what I'm going to do is I'm going to start off by giving you a mathematical formula that explains this idea of entropy of the universe, right? And then I'm going to give you some more real-world examples because, as I stated before, you actually understand the second law of thermodynamics. It's been guiding you your entire life. You just didn't know it. So we're going to put some words and we're going to put some variables to it so that now we have a better understanding of how it all fits together. And so the first place we're going to start is what we have over here, right? Bottom line is, this is what this equation tells us. The overall change in entropy of the universe, so delta S of my universe, is going to equal the change in entropy of the system plus the change in entropy of my surroundings. Okay, this is all that a change in entropy of the universe represents, right? System plus surroundings. We've seen this before. We talked about this when we were back in the first law of thermodynamics, back in thermochemistry. So it's still system plus surroundings, right? Hasn't changed. So what we mean by this is as follows. A system. So for example, let's go back to what we described in the previous episode. You're watching me on your laptop or your phone or your desktop, whatever the case might be. So that object, that thing that you're watching me on, right now has a high order of structure, right? It has a high degree of order, has a high degree of uniformity, right? It's going to look the same today as it did yesterday. It's going to look the same today as it will tomorrow. Now, for a moment, let's just kind of stop and think and go, what did it take to build that device, right? And maybe you can imagine, right, that somewhere there was a factory and people were putting the different circuit tree together, right, making sure that everything was lined up where it was supposed to be, and then at some point the screen went on, and then the speakers went on, and the hard drive, right, and all these different components kind of had to come together. And we can sit there and say that, well, you know, that took a lot of effort, took a lot of work, right? Now, in order to make the device that you're looking at right now, we might sit there and say that the change in entropy to create that tablet or phone or desktop that you're on right now, that created a lot of structure. So the change in entropy may have been a large negative value, right? It could have been. It makes sense, right? Because again, we had all of these scattered random parts that have all now come together. And they've come together in a very uniform and predictable way. My guess is if you took someone else's laptop or desktop or phone that was the same as yours and opened it up, everything would be exactly where it should be. You would be able to predict where things were, right? That represents organization and structure. But if we sit there and we think about it and we go, well, what did it take to put all those components together? And it's like, well, on one hand, you can now kind of imagine, let's say that it was literally an assembly line, so there were all of these pieces moving, and then everyone would come in and put in this one individual piece, this one little part here, one little part there, one little part there. But more so, did the factory that your device was made on, did it also make the glass of the screen? Did it make the keyboards? Did it make the microchips? And maybe the answer to that is that no, there were halfway around the world, there were, cranes that were digging up the minerals and the metals that then ended up in your device. And they had to be shipped to the factory. And the same way that the glass or the screen of your device, was made somewhere else and it was shipped to that factory. So when you start to think about all of the work that the surroundings had to do to make your device, suddenly you're going, wait a second, the change in chaos, the change in randomness, the amount of disorder that had to occur on the surroundings was ginormous, right? So we can look at something like we created an electronic device that you're using right now, and we can say that to make that device, there was an overall drop in randomness and chaos. And that makes sense. But in order to do that, the surroundings had to go cuckoo banana pants crazy in energy to put all those different pieces together. And so therefore, what we can see is that even though one of these had an overall drop in randomness, one of the partners was able to become more structured, what we see is that at the end of the day, the increase in randomness or chaos on the other side outdid it. So as long as the increase in randomness and chaos exceeds any increase in structure, then we would be able to say that the entropy of the universe is increasing. The entropy of the universe continues to be a positive value. Now, let's try this a different way and let's simplify the example in case that didn't make sense to you. So let's look at it from this perspective. So down here, right, we have a deck of cards. And notice our deck of cards. As it's being fanned out, you can see that it's very orderly and very structured, right? Now let's just stop and think about that. Order and structure means predictability. And the more you're able to predict what comes next, the greater the likelihood is that this is a highly structured system, right? And so as the cards are being spread out in front of you here, what you could do is that you could stop that video at any point and you could predict, if you're looking at an 8 of spades, that the next one is going to be the 9 of spades and the one after that is the 10 of spades, etc., etc., etc. Okay? So right now we have a system where I wouldn't say that it's completely uniform, right? It's not like they're all the 8 of spades or the ace of spades, but there is a high degree of structure, right? There's a predictability, there's a pattern. The other thing too is that I can tell you exactly where all those cards are. They're currently in the deck, right? So you and I are both looking at a deck of cards that are very organized. So let's ask this question. What if I wanted to randomize or create more chaos in this deck? What could I do? And of course the answer is, well, let's shuffle it. And sure enough, we can sit there and we can start to shuffle our deck as is happening here, right? And as we shuffle the deck and shuffle the deck, what happens is that now we begin to lose the predictability. So in other words, imagine that this deck that I'm shuffling here, at some point I stop and I pull the top card and I ask you, what is this card? What are the odds that you're going to be able to predict what it is? And the answer is probably 1 in 52, right? It's going to be almost a completely random guess. Now, what have we done? Well, in shuffling the deck, we've now jacked up the randomness. We've made the deck more chaotic. But is this as chaotic as we can make the deck? And the answer is still no. Well, why not? Because what were to happen if I were to take the same deck, except now instead of shuffling it in a nice organized way where we could predict where all of the cards were located, what if I now suddenly throw all of the cards up in the air? Right? See, because before, where were all the cards? They were in the deck. I couldn't maybe tell you exactly which card was on top, but I could tell you where it was located. Well, now that we're throwing all of these cards up in the air, they're landing all over the room. Where is that card now? And the answer is, I have genuinely no idea. So notice how we can increase the amount of randomness or chaos by taking more and more of that structure away, right? The less structure there is, the less predictability there is, the more chaotic, the more random our structure is going to be. So, why is this important? Why is this critical? Well, again, let's stop and think about this. I had a deck of cards. My deck of cards started off very organized, very uniform. Notice, go back to this first video here, when I first opened up my deck of cards and I spread it out, you could predict what card would come next, right? And then at some point after shuffling it and now tossing it up in the air, all the cards are random and thrown all about. I've lost any and all predictability. I don't know where things are located anymore. I can't tell you what card's on top. Heck, I couldn't even tell you where it's located in the room. So why does this give us an example of that second law of thermodynamics? Because you knew the minute that I started to flip the deck upwards, you knew that I was going to make a mess. Why did you know that? Well, because what happened was that in creating a huge mess, what happened to the overall entropy or the randomness of my deck? And you would say that it shot up. It went up insanely so, right? It went from all the cards being located here in my deck to all over the room. Well, let's talk about my room, part of the surroundings. What happened to it now that the cards are thrown all over the place? Is the room more organized or more chaotic? In other words, if, let's say, someone walked into your room and you literally had your cards all over the place, or, let's do it a different way, your underwear is thrown all about, would they say that your room is organized or that your room is a hot mess? And I would say that the room is a hot mess, that it's very disorganized. So in having the cards kind of spray out in all directions, I've increased the randomness or the chaos in my surroundings. Now notice the system became more chaotic and the surroundings became more chaotic. So the sum of those two means that the universe became more chaotic. And what we would expect to occur is that when I flip those cards up in the air spontaneously, they would make a hot mess, right? This is that second law of thermodynamics, that we have to create more randomness in our universe. Well, what were to happen if we were to violate the second law of thermodynamics? What would happen if we said, no, that's not what's going to happen. It's something completely different. We're now going to rewrite the second law of thermodynamics. In other words, we're now going to make it so that the universe became more structured. Okay, so what would that mean? That would mean that I would have to take my hand, put my hand out like this, right? And then somehow, all of the cards that are strewn all around my room, they would jump back into my hand as a deck, right? Well, why do I say it in that fashion? Well, number one, what do we need to happen first? First of all, we need that the system that was very chaotic and very unstructured becomes more structured. So the change in entropy of the system has to decrease, has to go down. But likewise, somehow, suddenly, magically, my room is going to become more organized. It's going to be cleaned up. We're going to take all these cards that were all over the place, and they're now going to go back into the deck. Now, if you were watching this on this video, kind of like what you see here, right, where it's happening exactly how I'm describing it, what are you automatically thinking? Oh, you're playing the video in reverse. I get it. But if you were looking at me in real time, if I was live in front of you and you somehow suddenly saw all these cards jump back into my hand, you would be like, this is magic, right? And that's just it. Violating the second law of thermodynamics will look to you and I as if magic happened. So we take it one step at a time, one tick at a talk, and you'll be there in virtually no time.